Hello everyone, welcome back to the session of data structures. In the previous session, we have seen what is stack and also how to implement a stack using arrays. In today's session, we are going to see how to implement a stack using linked list. After the end of the session, you'll be able to know how to implement a stack using linked list. Before moving on to see how to implement a stack using linked list, first we have to know why to implement a stack using list, even though we have implemented using arrays. There is a disadvantage with arrays that as we are using fixed amount of size for stack, so for inserting more number of elements it is not possible as the size is fixed. And also if we have used only some memory of size, so there will be a wastage of space. So these are the two disadvantages. Whereas coming to list, as it is in dynamic in nature, where in linked list we use dynamic memory allocation functions where we can insert the data items or delete the data items or manage the memory depending upon the data we insert, as it is very feasible to insert number of nodes dynamically. The stack size may grow or shrink as we are using dynamic memory allocation functions. So that's the thing why we are using going for linked list rather than arrays, even though we have implemented the stack using arrays. And before moving on to that, we need to know few more things, like as we have known the variable called as top, which always points to the topmost element of the stack. In arrays, we state that if size is -1, we state that there are no data items inserted onto the stack, that is the stack is empty. In a similar fashion, in linked list, when we represent a top equals to null, it means the stack is empty. There are no nodes inserted onto the stack. Both these are same when coming to arrays and linked list. This is the general representation of stack, where the top always represents the topmost element of the stack. Here, whenever a node is inserted, initially it is next value is assigned to null. As this is a representation of a node, where the node in a list is divided into two parts. One is data part and the next stores the address of next node. Here we don't have any after nodes, before nodes this, so we are treating this the next field as null. After that one more node called as 20 have been inserted, where after this node we have null. So we have one node called as 1400. So the address of next node, that is 1400, is been stored onto this. Next, after this we have one more node got inserted. After this 1800 node, we have one node called as 1400, 20, whose address is 1200, is stored onto this next field. This is how the links got established. This is how links got established between one and other node in the stack, where the top always points to the topmost element. Here we can insert the elements onto the stack by using push operation. It means we create a node and push onto the stack, and pop is nothing but we pop out a node from the top of the stack. Here in detail we'll be seeing what is this push and pop, how it has been represented in the form of a linked list. Here is the source code of how to push a node onto the stack. Initially, to push a node onto the stack, we take an empty stack. First, a new node n will get created by the help of this malloc function n. After that, we are storing some data onto that node, that is 10. Initially, we assign top equals to null. It states that there are no nodes onto the stack. Now in n next, we are storing top value, that is null. Here it is stored as null. Next, we are making this as top element. So this here n is nothing but this one, and we are making this as top element. Again, if I perform push here, or now the value of top is 1000. Here now the value of top is 1000. Now again, if I want to perform push operation, what happens? A new node, by the help of the struct node star malloc, one new node get created. This is n. I'm reading some data onto it. 20 is read. Now n next equals to top. If I am establishing a link, n next equals to top means in n next we are storing the address of top. The address of top is 1000. So in n next I'm storing 1000. So a link get established between these two nodes. Now this is the topmost element, so I'm making this as top. Now top is moved from this position to the 1004 node. Now again, if I want to push one more node onto the stack, one new node get created called as n. This is the new node. This is n. Now I'm reading some data into this node, that is 30. Now in this next I have to store the address of top, that is 1004. So n next equal to top. So in n next I'm storing top address, that is 1004. So a link get established. Now as this is a top node, I have to make this n as top. So top equal to n. So top is moved from this position to this position. If I have to insert one more node onto the top, then what do I do is I create a new node by the help of memory allocation function. I read some data into this node, that is 40. Again, I am establishing a link within the previous node and the next node, that is n next equal to top. In n next, I am storing the address of top, that is 1004. 1008. So 1008 is stored and I have to make this as top. So top is moved from this to this by the help of the statement top equal to n. Now this is top. This is how we create a node and we insert into the stack, and how we establish the link between these nodes on the stack. This is how a push operation works. When coming to pop operation, how we perform pop operation. We cannot perform pop operation onto an empty stack. First, we have to check whether stack is empty or not. If you perform pop on an empty stack, it doesn't work. So we have to check the condition, is top equal to null. We already know that when top is null, it states that the stack is empty. Here top is not null because top is pointing to the topmost node, that is 1012. So we go for, it is false, so we go for else part. Here temp equal to top. The top is assigned to temp. That is this node. Okay, now I'm printing the temp data. What is temp data? Here 40. The popped out data is 40 and top is moved to top next. What is the top next address? 1008. Where is this 1008? At this node. So top is moving from this node to this node. So if I want to delete this node, I have to use free of this temp. So when I perform free of temp, this node get completely deleted. This node get completely deleted. Now again, if I perform pop operation, I'm checking whether top is null or not. No, the top is not null because top is pointing to 1008 node. So initially I'm assigning temp. Next, I am printing this temp data, that what we are deleting, that is 30, and top is moved to top next. In top next, what is that? 1004 is it? 1004 is here. So top from here, it is moved to this location. Now I'm deleting this node by the help of free of temp. So this is deleted. Now again, if I perform pop operation, I'm checking whether top is null or not. No, top is null, not null. Top is pointing to 1004 location. So I go to else part again. Again, I'm assigning temp equal to stop. So temp is here now. Now, if I want to delete this node, top is to be moved to the next node. So top is moved to the top next, that is 1000. So top is pointing to this node by the help of the statement top equal to top next. So top is moved to this statement. Then I'm deleting this node by the help of this free of temp. Now again, if I perform pop operation, top is equal to null. No, in top 1000 is present. In 1000 is present. So I go to else part again. Again, I'm assigning this with temp. Now top is moved to top next. What is present in top next? Null. So top equals to null. Now I am freeing up this temp, that is this node. So this node get deleted. Again, if I perform pop operation, I will check if statement, is top equal to null. Now top value is null. Null is equals to null. Yes, the condition is true. So it prints that the stack is empty. The stack is empty. It means there are no nodes. All the 4 nodes got deleted by the help of this pop function. If again I'm trying to pop out something, it tells that the stack is empty. This is a traversal operation. This is to check that what are the nodes, that is what are the data items that are present on the stack. Initially, we cannot perform traversal operation on an empty stack because there are no nodes on the stack. For that, we check that top is equal to null. It states that the stack is empty. If not, here the stack is not empty because it consists of from 4 nodes, whereas top is pointing to the 4th node. Now, otherwise, to traverse this, what I'm doing is I'm checking if stack is empty. No, it is not empty. So it's going to else part. Here, what I'm assigning is I'm initially assigning temp to top. So temp is assigned to first node. Now, is temp not equal to null? Yes, temp is not equal to null because temp is holding some 1012 address. So what do I do is I print temp data, that is 40. 40 got printed. Now from this position, top is moved to top next. Where top is moved in top next, I have 1008 address. From here, top is moved to this state. Temp is moved to next node. So again, I'm repeating the while loop. Temp not equals to null. Yes, temp is not equal to null because in temp 1008 is present. So it goes to printf statement. It is printing temp data, that is 30. Again, temp is moved to temp next. In temp next, the 1004 address is there. So temp is moved from this location to this location, that is 1004. Again, I'm repeating the while loop where while repeats until the condition is false. Now temp is not equal to null because in temp 1004 is there. So it goes to into the while loop and it is printing temp data, that is 20. Now temp is moved to temp next. In temp next 1000 is there. So temp is moved from this location to this location. Now again, I'm checking temp is not equal to null because in temp 1000 is there. 1000 is not equal to null. So I enter into while loop and I'm printing temp data. Here temp data is 10. Now again, I'm moving temp to temp next. Temp is moved from temp next. So temp is moved to temp next, that is null. So temp is null. Now again, I'm repeating the while loop. Now what is temp value? Null. Null not equal to null. The condition is false. So we exit from while loop and meanwhile all the data like 40, 30, 20, 10 got printed. This is how we perform the traversal operation in linked list. Hope you have understood that how stack is implemented using linked list. Thank you.